자, 그러면 오전 세션의 마지막 강연자이신 조지 카트 교수님을 소개해드리겠습니다. 강연할 내용은 Combining Education and Research Programs to Connect Successfully Mathematics with Industry in France에 대해서 강연을 해주시겠습니다. 카트 교수님은 그레노브 알프스 CNRS 대학교의 교수님이시고 레보라토리 진 컨트만의 설립자이시며 이사직을 역임하셨습니다. 프랑스 고등교육연구부의 상임위원이십니다. 큰 박수로 맞이해 주시기 바라겠습니다.
Okay, thank you very much for this invitation and this opportunity to share a very small experience we have in France about industrial mathematics and maybe this opportunity to help you promote this topic in Korea. So I'm going to go over this this material. First, I will give you a little bit of history about how this thing started in France a few years ago. I'll show you a few illustrations of our programs, and then I will try to draw some conclusions of how things should continue, I hope, in France and in Europe. Well, what was the context in 2011? As you know, in France, well, mathematics are not so bad. Actually, we are ranked number two or number three in the world, depending on the way we count publication and fields medals. So mathematics are not bad in France, but the link between mathematics and economy in general is very weak, surprisingly weak. And we started to think about that some time ago, and finally we decided to do something about it in 2010, something like that, and to try to find a way to fix it somehow. And to fix it, well, we did not have to go through a lot of brainstorming. We looked around what was going on in countries in Europe, for instance, where things were much better, and also in Canada, where there is MyTax, which is a very successful program, which is now not only with mathematics, but with all sciences, all fields, but which started with mathematics. And we also learned from a study made by the European Science Foundation, which was called the Forward Look on Mathematics for Industry, which was done, I think, around 2009, something like that. And so there were a lot of recipes that were implemented in these different countries, and or a lot of recommendations which were done by the European Science Foundation, and we just looked at that and see how this could work in France. So the result is that we created in 2011 an agency which is called Agency for Mathematics in Interaction with Enterprises and Society. So I guess enterprises and society is the definition of industry that John Ockendon gave earlier. Well, the structure of this agency is actually it's a national laboratory in France, a national mathematics laboratory, which is really the bridgehead of a network which contains all mathematics laboratories in France, which is let's say about 50 laboratories nationwide. So it's a CNRS laboratory, a joint laboratory between CNRS, the University of Grenoble, because I was in Grenoble at that time, and I'm still in Grenoble, and INRIA. INRIA is the French National Institute for Computer Science and Applied Mathematics. And the money came essentially from ANR, which is a national agency for funding agency for research. And we took actually the opportunity of a big program in France, like, I mean, French like big programs. So there was a program in 2011 to promote excellence centers in all fields of science. So we decided to apply for this program, although we were not supposed to be an excellence local center because we are really a network, a nationwide network, but we still applied, and we were lucky enough to be selected. Actually, we were only 2 or 3 laboratories, mathematics laboratories, to be selected for this first call in 2011. And so we were pretty lucky, or we were pretty good. I mean, I don't know. Anyway, so we got this award, which is not a lot of money. It's 5 million euros for 10 years, so it's not that big, but we found it enough actually to start interesting things. So what? Okay, I think I did something wrong here. Okay, I should not have played with the keyboard, so I have to play it. Can you show me how to put it up? Here it is. Thank you. So I'm going to use this. Okay, so what are our programs? Basically, we have research programs, education programs, and we have something about networking and something about advertising, okay? So the research program basically is very simple. We give a little bit of money to start exploratory projects between laboratories and industry. So very small projects. In general, it's the first contact between the laboratory and the company, and we give a little bit of money to have people work together for 1 year. So we have starting grants, and we have more elaborate grants, so where people can hire engineers or postdocs to go further in the collaboration. So we have this part of this research program. And then we have also training actions. So we have study groups that were already mentioned several times, which are a very important tool to promote interactions. We promote internships. We promote also the organization of meetings where industry, laboratories, and students can meet on specific topics. And several other things that I will mention later, maybe. And then we have this network of facilitators. So facilitators are people who are distributed nationwide and who are supposed to go to companies and to explain to them that maybe there is some mathematical content in their topics, and maybe that will be beneficial for them to discuss with mathematicians. So these people do the connection between mathematicians and companies, depending on the topic, depending on the field of the mathematician and all that. So it's a very important work, very difficult work, but very important work. And then we try to advertise in a systematic fashion about mathematics, and in particular industrial mathematics. So we organize events. We try to showcase success stories or events where these things are discussed. So that's also a very important and very, well, quite a challenging task to go to the newspapers and to try to explain to them that they should talk about industrial mathematics, that there are very important topics there, and that the economy needs really mathematics. So exploratory projects, as I said, we have starting grants or consolidated grants, and what we target, and that will be something that will be all along my talk, we specifically try to target SMEs, small and medium enterprises. Why? Because we think that innovation is really goes through these SMEs, and we also think that large groups don't really need us because they already know how to connect to mathematicians. Well, not always, but sometimes at least they know how to do it. But in SMEs in general, you don't have a single person who is able to understand what mathematics can bring to them. So this is really an important target, a difficult target, but also a very rewarding target. Okay, I will come back to that. So the topics are, I mean, all topics, of course, and statistics is a big field for these SMEs and for industry in general. signal processing and data science in general is also a big topic. Scientific computing and all domains of application from energy to transportation to finance and software. Okay, so these are the exploratory projects. And then we have the, I mentioned the study groups. Our approach of study groups is maybe a little bit different from what we learned so far. We try to have a bottom-up approach. That is, we instead of organizing ourselves all the study groups, we go to laboratories. We try to explain them what study groups are about, what would be the benefit for them to organize study groups, and then we convince them to organize these study groups. So we help them organize them, and we have some guidelines that they should follow, and we give a little bit of money to a little bit of money for grants for students, and then the labs they stay in line because we don't want to organize too many at a time. So, but they are very much interested, and you see the name of the cities where they have been organized. So maybe you don't know these cities because they are not that big cities, but they are all over the country. And I think it's very important to have these study groups distributed nationwide because if we want to reach small or medium companies, I mean, we have to be, it cannot be centralized, okay? We have to be everywhere in the country. So it's very, and the labs are everywhere in the country, so that's, again, the good way to connect to SMEs. So far, we have organized 14 weeks, which involved about 300 PhD students, almost 50 companies, okay? So, something which is also maybe a little bit different from the model of Oxford is that we do not really allow senior people to participate in these study groups, or at least they supervise in the sense that they get involved in a study group only if the group is stuck at some point, but they don't really contribute to the work of the study group. Because we are afraid that if there is a senior person, PhD students will be somehow inhibited by the fact that there is a senior person, and okay, that's how we do it. So this is about the study groups, and then I mentioned that it's very important to advertise and to go to the press, to go to the government, to go to the society in general, and to tell them that industrial mathematics are important, and that there are a lot of achievements already, and there should be even more. So we have several things in our program to do that. We started to organize a national math job fair in Paris. And with the French SIAM and the Society for Statistics, also SFDS. So it started in 2012. So when we started that, we were a little bit afraid, is it going to work or not? I mean, is it going to, how many people will come to this math job fair? And we were surprised that, well, it was a success from the beginning. We had at the beginning 800 participants. And 2 years later, we had 1,500 participants. So most of them are students, but we have also, of course, a lot of companies which organize booths and which take CVs and discuss with students. And we have some keynotes on specific topics organized during, it's a one-day event. So it's working very well, and we were surprised it would work so well. So it's just mathematics job fair. And something we started to also to organize 2 years later is we give a little bit of money to a PhD award for mathematics, industrial mathematics. So I think it's also very important to promote that among PhD students. Okay, you can tell them, okay, if you do a good PhD in industrial mathematics, you'll get a little bit of money, and you'll get to give a keynote in some conference, and so on. And so it's also good for the companies to show them that there is that this is rewarding to connect to mathematicians. We have also set up at about the same time a collection, some kind of archive collection for preprints dedicated to industrial mathematics. So I think that goes along the same lines. We want to promote this type of activities, even if it does not, even if this publication don't go to classical mathematics journal. So we have this collection which has about now 100 publications. And we try to make portraits of mathematicians in industry. We try to advertise for success stories and these kind of things. And again, and we have now hired somehow an agency which work with us, a press agency which work with us, and which systematically go to newspapers and try to pass messages to newspapers. In particular, when there is a big mathematics event, then we get some kind of newspaper coverage of mathematics, or in general, and industrial mathematics in particular. For instance, when there was the ICM last year, we had several articles in newspapers, in general newspapers like Le Monde, Le Figaro, I mean, these newspapers, this type of newspapers, and also on specialized newspapers about mathematics. So it's good also to have a systematic approach of how to reach to this kind of public. Okay, so to promote the interface between mathematics and industry, we are also a database. We try to set up a database of industrial projects in laboratories. So we have a map of laboratories, and this map connects to a database of projects in industrial mathematics. And the last thing I want to mention about this part of the program, I think that was mentioned by John O'Kendon. In the UK, there was a study made by Deloitte about the impact of mathematics in the economy. It was in 2012, and I think the Netherlands did it also in 2014, so we wanted to do one also for France, and it came up this spring, and we had a lot of very strong media coverage for the results of this study. So it's very, I think it's a very good thing to do that. Although we knew in advance what would be the output of this study, because there was no reason it would be very different from the UK or from Netherlands. But I mean, at least it gives you the opportunity to have a coverage of how mathematics impact industry. So we find more or less the same figures than in the UK or in Netherlands. 9% of the jobs are directly impacted, 15% of the gross added value, which means that the jobs are kind of highly qualified jobs, and 40% of the key technologies are impacted by mathematics, and you see the strategic domains that mathematics impact. So there are a lot of figures in this report, and well, all these figures show that mathematics are very important in the economy, and that the importance of mathematics is growing, actually, because these numbers, there is also, it's also shown that these numbers increase, and they have increased, for instance, 1%, the number of jobs have increased 1% in 2 years. Okay, so it's increasing, and we have to be prepared somehow to find enough students to fill these jobs somehow. That's the message, okay? So the situation is like that, but if we want to, I mean, to meet the challenges to come, we have to be able to educate more students in mathematics. That's the message, basically. So this network of facilitators, I mentioned that it is very important to have people dedicated to do these connections to, in particular, to SMEs. So it's kind of difficult because, again, SMEs, they don't have the culture, they don't have experience in using mathematics in general. But as soon as you start to talk to them and to show that in their problems there is some mathematical content, then it's very rewarding, because they are, I mean, if they put aside, I mean, their fear of mathematics somehow, and if you try to use the right vocabulary to talk to them, then they are ready to understand that actually there are mathematics in their problems, and they need to talk to mathematicians. So go to them and to start connect to these SMEs, you have to be very quick. I mean, to be flexible, also to find the right time scale to respond to their demand. I mean, you don't have. I mean, if a SME come to you with a problem that they have to solve within 1 year, you don't have to propose you don't propose a PhD for that, of course. So you have to be, I mean, to be able to adapt the time scale of your program to answer the demand of the SMEs. Okay, so I'm going to show you a few illustrations of this of our programs, and in this illustration, I'll try to show you that you have to connect different type of programs to make it successful. So I'm going to show a mediation structure which is operated by mathematicians. I'm going to show you how mathematicians can help SME to go to HPC. And I am going to show you a startup which was started with the help of mathematicians. And I am going to discuss very quickly a topic developed by Biomérieux in biology. Okay, so something that we try to promote is to have local, regional centers for industrial mathematics, because we don't want to have a centralized organization. We do not do ourselves a contract with enterprises. We just try to distribute the work among the labs. So what we want to have is to have some relay to these labs, which are centers with some critical mass, which are able to connect themselves to SMEs. So there is one in Grenoble, actually, which was started more or less at the same time as AMIS. The goal of this center is to promote interdisciplinary research, and in particular, industrial research with SMEs. So this is some kind of a center where SMEs goes to, and they ask their question, and then the center, in a very quick way, is able either to say, okay, this problem is you just need service, okay, and you don't need mathematicians for that, because there is no real mathematical research content in your problem. So we redirect you to a service enterprise, which is going to answer your demand. So, and in the case there is a research content in your problem, then we are going to connect you to mathematicians. That's basically what this center is doing. So there are a number of grants which have been started since 2012, and these grants are very small. Well, not small, but, well, yes, they are small. I mean, you don't need big grants, I mean, but you need to have connections. And in general, you start with a small grant, and then the enterprise come again with a bigger grant, and so on. But I think it's important to have, it's better to have many small grants than a single big grant, okay? Because then it's more, you can be more reactive. And you have also, I mentioned that you have a few startups which were initiated by this center. The second example I want to give is something about HPC. So HPC, high performance computing, is a big keyword, and a very fancy keyword, and there is a lot of money to HPC, and in particular to HPC for companies and for SMEs. But in general, SMEs, they don't have really needs in HPC. They have needs in simulation and numerical algorithms. So what we do is we try to have this HPC fancy title to attract SMEs and to show them that before going to high-performance computing, maybe they need to think about their model, they need to think about their numerical methods, and they need also a way to understand algorithms that are in the software that they use without knowing really what's going on in their software. And this is how we use somehow HPC, this keyword, to connect to SMEs. And this is how we did it for this company, Principia, which is specialized in coastal engineering. So we now have a connection with this enterprise to help them define better algorithm for this kind of fluid structure interaction problems that they have to deal with, and to have better algorithm which ultimately will go parallel and will go HPC. but HPC was not really the main topic. It was really, the topic was to help them do efficient numerical simulation. And we were able somehow to connect to this company with an initiative, HPC PME SME, which is an initiative to help SME go to national platforms to do HPC. The second example is, I don't know when I started, so I don't know how much time I have left. When did how much time do I have? 5 minutes? Okay, so I'm going to go a little bit faster, maybe. So Pollen is a startup which was created in Grenoble also, and it's a software editor which is specialized in nanomaterials. So nanotechnology is a big thing in Grenoble, and with a lot of companies and a lot of research centers dedicated to nanotechnology. And this company wants to take images and to be able to detect defects in nanomaterials in a very quick way. So it's basically image classification, machine learning, and this type of thing. So this company managed to, was helped by mathematicians to go on the market somehow. And this was initiated by a support from this agency that I was running and the local center that I was talking about in Grenoble. And this was started by exploratory projects that we funded at the beginning, and now it's a very successful company which does not need our help anymore, and which is still connected to mathematicians. bioMérieux is a leading group in vitro diagnostics, so it's a microbiology group. And this story started with a study group in Marseille, and the topic that they submitted to this study group was to be able for a given antibiotic to target a specific part of a bacteria. So you know the problem with antibiotics is that they have a big range of action, so they somehow promote the resistance of bacteria, a very strong resistance of bacteria to antibiotics. So what bioMérieux tries to do is to have antibiotics which target very specific parts of the DNA of a bacteria to avoid this resistance to antibiotics. So it started with a study group, and the company was so, well, first the company came to us and said, we don't have many collaboration with mathematicians, so we told them, okay, why don't you go to a study group to test mathematicians somehow? So that's what they did, and they were so happy about the output that the PhD, one of the PhD which was working on this topic, he got a consulting job at bioMérieux, and he's going to be hired by bioMérieux after his PhD. So it's one way to, you know, that study group is one way not only to educate people, but to start connection with companies. So what my conclusion is really that for us, what I think is successful is that you have different type of program which are connecting laboratories, students, companies. So you have education programs like study groups, consulting PhDs. You have exploratory projects between company and laboratories. You can also organize thematic workshops between companies and laboratories. And you have this network of facilitators to promote these connections. And I think it's important to have the different type of programs that go from, and you can somehow go to a company and say, okay, you asked for this, but this type of program is also maybe going to help you, and then you can come back to us for this type of program, and we can help you in different ways somehow to go for long range, so I would say, collaborations in this with mathematicians. And one thing that we have to promote with companies is that mathematicians are a very good entry point for companies when they want to go to HPC. I gave you an example about this company going to high-performance computing through mathematicians. And data science is another field where mathematicians can be very helpful for companies. So that's also a message that you have to do. So here are a few challenges that we have to meet still. I mean, continuing education is a very important topic, and so far we are not very well organized to have continuing education programs in mathematics. So each university has this type of program in different fields, but we have no visibility of continuing education for companies in mathematics. So I think it would be very nice to have this kind of visibility so that mathematics see, I mean, going to some portals, they see that if they have a particular need for their engineers in mathematics, they can go to this place or that place to have this education, this continuing education in statistics or in numerical simulation, optimization, or whatever. Another challenge is it's important to reach to high school. Okay, it's good to reach to PhD students, of course, but I think we really have to start with high school students, and it's more, of course, it's a big topic to go to high school students and tell them that mathematics are not only a beautiful field where they can use their brain and their imagination, but it's also a field where you can make a difference in innovation and in the economy in general. Pure mathematics, that was also mentioned, is sometimes a kind of field which resists to industrial mathematics. So more and more pure mathematicians can start to understand that many of the challenges to come are going to use fundamental mathematics, but there's still work to do in this direction. Another topic which is, I think, very important is to reward somehow industrial collaboration in academia. So it's a very hot topic, I would say. As you know, I mean, publications are rewarded in academia, and industrial collaboration is a field which requires a lot of energy, a lot of time, and when you spend time discussing with companies, you cannot write publication, or you write less publication. So it's very important that these interactions between mathematician and industry is recognized in the academic world as an important thing comparable to publications. So this is a very difficult fight, but we should not give up on this fight, and I think it's important. Another thing which I think is important for mathematicians in industry is to build communities in industry for mathematicians in specific topics. Data science, for instance, is one topic, and I think it will be interesting to build communities in the sense of social networks of mathematicians in industry that will be able to share experience and to share knowledge from different point of view and different fields of applications, and that will be very stimulating also for these people because very often when you have a mathematician in a small or medium enterprise, he is kind of isolated in his enterprise. So if he feels that he is part of a larger community, I think it will be more stimulating for him and more rewarding. And the last thing I want to say is that you have, in France, we have also to think at the European level. So I think John talked about ECME, but there's also another thing which was recently created in Europe, which is called EUMathIN, European Mathematics for Industry, which was created in 2013. And this is some kind of European network of national web networks. So it started with six national networks, including the French network, British network, there was a German network, and so on. And now it has been an incentive for all countries to start the similar networks in their own countries. So now we have 14 national networks in Europe dedicated to connection between mathematicians and industry. And what is interesting in this network is that it is now able to do some lobbying at the European level to write mathematics as a key enabling technology and to have the mathematics keywords more visible in the programs, in the research program at the European level. So I think it's a very important work to do in Europe to do this lobbying at the European Commission level so that there is more money for mathematics in general and for industrial mathematics in particular. Okay, this is all. I thank you very much for your attention.
네, 혹시 질문 있으시면 질문해 주십시오. 네,
마이크.
네, 한국말로 하니까 편해서 좋은데요. 제가 그 여러 가지 사례 성공적인 얘기를 들려주셔서 굉장히 도움이 많이 됐는데, 제가 저는 그 대학의 교수로서 이런 산업수학 프로젝트에 이제 참여를 하게 되면 회사 그 수혜자는 이제 회사와 거기에 연구자로 볼 수가 있는데, 그 연구자들 중에는 교수들도 있지만 많은 포닥하고 포스닥과 대학원생, 그레이저 스튜던트들이 있는데, 제가 교수들은 그 리서처인 동시에 에듀케이터라고 생각을 하는데, 그 에듀케이팅 하는 교육자 입장에서 그 학생들 또는 포스닥들의 그 프로젝트가 끝난 후에 어떤 좌압을 잡는 그런 문제가 굉장히 중요하다고 생각을 합니다. 그래서 거기에 참여한 학생 또는 포스닥들의 취업에 대해서 그 프로젝트가 끝난 후에 그 프로젝트를 같이 진행했던 회사로 도로 가는지 아니면 어디로 취업을 하는지 그런 게 알고 싶고요. 그 다음에 두 번째로 이렇게 성공적인 케이스가 물론 많겠지만 분명히 그 중에는 실패하는 경우, 그러니까 그 프로젝트를 성공적으로 수행하지 못했다거나 만족할 만한 그 결과가 회사에 그 주지를 못했을 때 그런 경우에는 어떻게 하는지, 그런 두 가지에 대해서 좀 답을 듣고 싶습니다. 예.
Okay. First of all, I would say that mathematicians who want to go to industry, they have no problem to find a job. So what we need is not more jobs for mathematicians, but more mathematicians for jobs. I am convinced of that. Of course, there are cases where mathematicians don't find jobs in industry, of course. But in general, I would say that if they have the proper education, the proper master, the proper whatever, they find jobs. And when they are involved in a project, in a specific project, so either at the master level or at the PhD level, I think the fact that they find jobs or not is not really depending on the success of the project, because the industry always finds benefits in the interaction. I mean, I don't know any example of total failure where the enterprise say, okay, no more mathematicians. I don't want to see any more mathematician. I don't want to hire any mathematician. So it's always successful at some point, and enough for the students to give him a training, good training, and to find a job. Maybe not in the same enterprise, but in industry if he wants to go to industry. So we really need to find more mathematicians, and to find more mathematicians, we need to advertise that mathematicians find easily a job, and it will be more easier and easier because there will be more and more jobs with the content in mathematics. That's what I am sure of.
네, 한 분만 더 받겠습니다. 잠깐만. 앞에.
Hello. Thank you for coming to speak with us today. Just one question. As an undergraduate, do you have any advice that you would like to offer to people, young people, who might not have experience in this field yet, but are interested in going further into this field? I, for example, am a history and science major, but I'm certainly interested in this field, and I was wondering if you had any advice for people who might not be in this field yet.
Which field? Which field are you? Sorry, I did not understand.
History of science.
History of science? I don't know about the history of science, but what I see is that in these study groups, for instance, you see, so you have very specific topics in a very specific applications, and we have students who come with different fields, okay? So pure mathematician, applied mathematician, and we avoid making groups only of students which are who are specialized in the field, in the topic which is given by the industry. And what we see is that all students, even those who are not specialized in the field, in the topic, in the specific topic, contribute because of their background. And that's a very important thing to see. I was surprised myself to see that, actually. Because of the background that you get in your education, in your math education, I mean, you must be convinced that you can contribute to a topic in the industry, even if it's a very specific topic which is mostly statistic or mostly simulation, because you have this background. I don't know how to explain it, but I should maybe give example, but I didn't prepare example for that. But it's very, what enterprise realize in these study groups is that it's really the training of mathematicians with the full background of mathematics involving, including pure mathematics or applied mathematics. It is this background which makes them being able to react to a problem by sometimes shifting a little bit the problem, which is important because, sometimes the answer comes by shifting a little bit the point of view, okay, and not doing the usual thing. So very often this gives new ideas to companies, so maybe these new ideas will not go all the way to the result, but that's very important for them to get some new avenues to attack their problems. And mathematics students can provide this because of their background, even if they are not specialized in the topic. So I don't know if I have answered your question, but we really insist on the fact that we try to mix different backgrounds in the study groups. And okay.
시간이 좀 많이 지연이 돼가지고 좀 오래되는 바람에 혹시 질문을 오후에 사실 5시 반에 패널 디스커션이 있습니다. 그래서 사실은 오늘은 이 강연을 끝나고 질문 시간이 없었는데 강연자분들의 요청에 의해 가지고 지금 한 30분쯤 이렇게 좀 길어졌거든요. 그래서 굉장히 죄송한 말씀 드리고 아주 짧게 그러면 마지막으로 질문 하나. 예.
Well, thank you so much, Professor George Henton Carter's. Your today's message is a very incredible our futures, and in the long run, you will be great. Thanks so much. I'm little kind of afraid. Where ours is a mathematics really is developed and enhancement from now and the future. By the way, this is a title, how can I industrialize, where the user is a problem, is a very nice problem. But we are the mathematical, the academic, the professor and student, only the organization study, but analyze different is business, for example, agricultural, and the others is industrial. There is a selection, it's up there. So how can I, there the individuals celebrate business we are contributing? That is my question. Thank you so much.
Okay. I'm not sure I understood very well your question. You from what I understood, you asked me how to prepare students to go in in different fields of applications, or was that the question? I don't think there is a. I don't think there is some specific training that you should give students for going to specific applications, if this is the question. I think, again, what is valuable in mathematics is a whole background of mathematics, and the fact that in a different application you have to master, or at least to be able to understand things which are connected, let's say, to analysis, but also to algebra. And you have also, I think something also which is very good in mathematicians is, the rigor that they have. I mean, when they have a problem, when they have results, when they have data, they always question it. Okay, what is the validity of these things? Okay, where it comes from? How can you validate it? And they have some. What companies like is that mathematicians, they don't just take things for granted, and they really want to find the roots of the things and to be able to systematically validate the things and to question the models and to find a way again to quantify things and to go. Okay, that's and you don't need any specific mathematical education for that. All studies, all mathematics are about that, I would say.
예, 하여튼 오늘 오전에 열심히 강의해 주신 우리 세 분 교수님께 다시 한번 박수를 보내드립니다.
I have some leaflets for this French agency on my desk. If you want, you can.